What's up guys, welcome back to another video. Skyt here, and today I'm showing you how to make a DLL injector with C++. This is a very easy method, and yeah, before starting, please leave a like and subscribe as it helps me a lot, and maybe join the Discord server down below. And of course, if you're feeling extra well today, you can click the join button and maybe join the channel membership. But without further ado, let's get started with this. So this also works with any front-end graphical interface. If you want to use IMGUI or other things you've seen on the channel, you can definitely use, so that won't be a problem. And second of all, I do have a DLL here which I've just created, which just opens a page when injected, a Chrome tab. So this is for testing purposes at the end, so I can show you how it works and if it works, but it will work, don't worry. So let's get right into it. We're gonna open Visual Studio 2022 or whatever you wish, and we're gonna create a new project. I'm not gonna do it in a IMGUI example right now. I'll do it simple in a console application, but if you want, just go straight to your IMGUI program. I'm going to do everything in only one function, and I'll show you exactly what you need to add. So it should be fairly easy to implement anywhere. So we're gonna create this console application, and here we are. I'm gonna delete everything for now so I can tell you exactly what you have to do at first before starting to write actual code. So first of all, we have 4 libraries we need. The most important one, starting with the Windows API, windows.h, so include windows.h. Then we have, for all the tools, the snapshot functions, we have TL help 32. After that we have string, because we're gonna use some strings for the path and for the process name and stuff. I'm not sure if we need it, but it won't hurt. And then we have the almighty YoStream to get some input. After you have these 4 libraries included, you also need to have the kernel 32 lib and the user 32 libraries inside your project. So how you're going to do that, you're going to go to your project here, right click and click properties, or click alt enter directly there. And here you're gonna go to linker and then to input here. So under linker, input, and you're gonna see additional dependencies. Here you're gonna click this arrow, click edit, and then simply write them here one under the other. So kernel, I hope I wrote it right, 32.lib, and then we have user 32.lib. And you're gonna click apply. Alright, we are now good to go. Let's create our int main here. We are going to do our function separately, not in int main, but I'm going to create it now real quick so we can run the function at the end. And let's begin. So we're going to do our inject function as a bool, so we can check if it has failed or not at the end. It will return true if injected, false if not injected. So we're going to type bool and then our function name. I'm going to name it inject_dll. And we're going to take 2 parameters here. We're going to take the process name and the DLL path. You can use a few variables for this, a few variable types for this. I'm going to go with a constant string, so const std string, and let's say process name first. And then you're gonna copy and do the same for the DLL path. So let's say DLL path. And we can now open the function. First thing we have to do is getting the snapshot, actually creating the snapshot. And I'll show you how to do that. Use the handle and name the variable h_snapshot, or however you wish. I'll name it h_snapshot, it's very intuitive, you know what it does. And you're gonna use the create tool help 32 snapshot, I think, yeah. And here is gonna ask for the flags and the process ID. For process ID, we're going to type 0, and for flags, we're going to have th32cs snap process. And as I said, for ID, we are going to have 0. I'm actually going to do some debugging here, so you know. So if you want to have debugging along the way, you can type these things. I will specify when it's a debug code. Like here, I'm going to check if the snapshot has created successfully, and if not, we're going to throw an error. So if h snapshot equals to invalid underscore handle underscore value, then we are going to throw an error. So std sir, let's say, I don't know, failed to create process snapshot, and we are going to return false, the DLL inject function, so the program knows the injection has not been made. Alright, after we've created our snapshot, we are going to create our process entry, which is very intuitive again, process entry 32, and we are going to name it P32, PE32, process entry 32. And now we're going to set the size, which we're going to do it very generic, P32 plus .w dw size here is going to be equal to size of and process entry 32. Then we need to try to get the first process, and we throw an error if that doesn't happen. So if not process 32 first of h snapshot and p32. So we're gonna run this function, and if it returns false, then you can also debug it here and say what gone wrong. So again, sir, whatever failed to get first process. And then you also close the handle to clean up behind you. You are going to close the handle only if it fails, so don't worry, it won't close if everything goes right. And then you can return false again. If you don't want to have the debug part, you still need to have the process 32 first part, so just write it like this, without the if, without everything else. Going forward, we need to find the process by the process name. We don't have the ID, we need the ID to be able to inject the DLL, and we are going to take in consideration the process name. So let's create our process ID here as a D word, process ID equal to 0, and we're going to have a do while structure here. So do, and we're going to say if std string, or you could use using namespace std here to not write std every time. So if std string of p32.scexe file equals to process name. So if that happens, we are going to attribute to process ID the value of p32 dot, and here you can actually find, I'm pretty sure, th32 process ID, and then we break the do while loop. We should also write here while, and while here it's going to be while process 32 next h snapshot and p32. So this is our little thing here. Let's see what this wants. So it asks for a wchar, and this is an std string. I think we can fix this by going to properties, and somewhere around here in advanced it should let me set it to multibyte. I'm not sure if this is the solution, but it seems as this is the solution. Nice. So just change it to multibyte and you don't have any problems. Let's put the semicolon here as well. All right. So if you get that problem with a string there, change it to multi-byte. I think you should change it to multi-byte anyways, makes life easier. But if you are already in a project, do convert that string to a WHR. Don't change it to multi-byte, you might break many things in your project. So if you're already in your project doing this, try first fixing it rather than changing to multi-byte. That might cause more issues. Anyways, now we can close the handle, we don't need it anymore. So close handle of H snapshot. Going further, we're gonna throw an error. This is a debug code, yeah. So we're gonna throw an error if we haven't found the process ID. So if not process ID, we're just gonna say std, let's open brackets here so I can say std sir, no process found, and then obviously return false. Going forward, now we have to open the process. Also, if I didn't tell you, you can find this code in the description. You don't actually need to watch everything if you don't want to, but it will be on my website. Anyways, now we open the process. So handle H process equals to open process. I think, all right, we have it. Then for the first argument, which is desired access, we need all access. So process all access. Then for the inherit handle, we type false. And then the process ID. We open the process like this. Also, we can debug it again here and say if not H process failed to open process. Let's do this. Just change here. This is a debug code again. If not H process, we're gonna type here failed to open process. So you know, if anything goes wrong, you know where. All right, going forward, we need to allocate memory now. This is the, I wouldn't say more complicated part because there are 2-3 lines of code anyways. It's nothing complicated, but it's more complicated to understand if you want to see the logic behind it. I'm not going to go in depth. I'm not going to explain the logic behind it. You should learn C++ if you want that. But we are going to allocate memory in your desired process you just opened for the DLL. So lp void alloc memory will be equal to virtual alloc ex off, and we're gonna go H process. After that, for lp address, we can type this as null pointer, we don't really need it. And then we need the size. The size will be of the DLL path.size because we can access that size, and we're gonna add 1 to it, and then it's gonna ask for allocation type, and we're gonna have mem underscore commit and mem underscore reserve. And the final thing, the protect, which will be page read and write. So we can read, we can write, do anything we want. Again, here you can debug if you want. You can type if alloc memory. I'm gonna spare you some stuff and simply write directly std sir failed to alloc memory. And make sure you close handle H process here inside the if alloc memory doesn't work. So if you want to clean up here and end the program here, close the handle H process if alloc memory null. Only if the alloc memory is null. Okay, don't close the handle here in the program, that won't work anymore. What we are going to do now, after we allocated the memory, we're going to write to that memory we allocated. We're going to write our DLL. So we can do this in a way, let me think. In a way we also debug it at the same time. So let's do if not write process memory. We don't do it like this, and again h process alloc memory here for the base address, then the DLL path dot, and I think it asks for a, okay, we need to convert it in a constant char, so dot cctr. Then we need the size, which is again DLL path dot size +1. And then for the number of bytes written, if we set it to null pointer, it will get them automatically. So if this doesn't happen, but to check if this happens or not, it still executes this function. If you want to not debug it, you can simply execute the write process memory function here without the whole if statement thing. But if that doesn't work, we are going to display fail to write to memory, fail to write to memory. And here we also clean up afterwards, so virtual free eggs h process alloc memory and 0 and mem underscore release. This is to clean up, okay, so don't do this outside of this, and also close the handle for h process. It's always good to clean up after yourself, not leave random things. It's a good practice if you want to become a full-time developer one day. I'm not one, and I don't think I will become one, but we'll see. Okay, so after we wrote to process memory, we need to get the module, the kernel, DLL, and after that we're gonna create the remote thread, and that will be kinda it. You're gonna get some things here saying alloc memory could be 0, but if it's 0, then we checked for it, and here as well alloc memory could be 0, doesn't matter. All right, so h module, we don't have much left. We're gonna use the h and just say kernel 32 equals to get module handle a of kernel 32.dll. Here you can debug again, saying if not h kernel, then throw a ser and then use like here. Actually, you can just copy this, but instead of here write not and h kernel like this, and here modify this, just say I don't know, failed to get handle to kernel 32.dll. all right, you should have some \n's in case you have, actually only one of these will happen at a time, and if it happens then it breaks. So again, for the kernel, same thing, virtual free x close handle to clean up after yourself if the get module doesn't work, if you can't get the handle. And now we create the remote thread, and this is the actual LoadLibraryA I was talking about at the beginning. Handle, again, many handles. H thread equals to create remote thread, and it's gonna ask for a few stuff. Obviously the process first, which will be our H process. Then it's gonna ask for some LP security attributes. As far as I'm concerned, it should be fine if you write null pointer here. Size t for the stack size, which will be let's see. Okay, so LP thread start routine to convert it, and it's gonna be get process address, and here we use the h kernel 32 and then the load library A. And after that we are going to have, what is this, the start address. The start address is kept in alloc memory, Then for creation flag, no, where are we? LP parameter 0 and creation flags. No pointer. Let's see. Identifier get process address unidentified. I wrote address wrong. It's address with double D. Is incompatible with a parameter of type size T and OP thread start routine. I think I messed things up a bit. Oh yeah. Okay, the stack size should also be 0. We are missing a 0 here. Alright. Everything is fine now. Okay, we're missing the 0. I was wondering. Yeah, so this is not the stack size, it's actually the start address. I'm in another universe. The alloc memory is the the parameter. Alright, sorry. I'm very tired at this hour. Here you can once again debug it if you wish, if hthread. So if the thread hasn't created successfully, exact same things as here, throws here, failed to, let's say, to create thread, virtual free ex and close handle, and then return false. And now we have 4 more lines of code, actually 6, but we wait for single object and wait for hthread to infinite. All right. Then we can free everything. Now we clean up. At the end, we always clean up. Now we have finished everything. After this line, it should be injected. It should have no problem. So now we can free everything. H process, alloc memory 0 and mem underscore release. And we close both hthread and h process. So hthread and then again h process. We can do a cout at the end. Let's say DLL injected successfully. Did I write that? All right, yeah, I write it. And now we can return true at the end. Literally there are more lines for debugging and cleaning up than actually injecting the DLL, but in our int main now we can create strings for process name and for DLL path. So let's say std string. Let's go name for the process name equal to, I don't know, notepad.exe. Let's say that. Let's inject it into notepad, it doesn't really matter. And for DLL, it's going to be, let's go C slash or 2 backslashes. I think slash is fine. DLL1.dll. We'll check if this doesn't work. It should work. Obviously replace this with the path and the process name of your choosing. Inject DLL. Alright, so now we call our function inject DLL of name. I think we've put first, yeah, the name and then the path. So name and then DLL, which I think not as pointer. No, okay. All right, now let's move our let's create a notepad here, open a notepad.exe so we have it opened. And God, I have so many things opened here. I need to close them all. Bye please. For some reason it stopped responding. How can notepad stop the responding? Okay, I'll be back in a second. All right, let's just put my DLL into C now. How could this stop working? Alright, we have it here. Let's close it, and it's now time to check if this works. Switch to release, because why not? Works faster. x64, and let's go. Local Windows debugger. Alright, so the fixes is you need to do as I said, you need to convert it here into a W string, the process name. Remove the string here, leave only p32 as the exe file, and here when you inject the DLL, make the name again a W string and add an L before the actual string. For some reason it didn't work with notepad.exe, but let's test it for the third time with chrome.exe and run the debugger. Hey, it worked.